Right. Hey, Abyss. I'm Flora Douglas. We're doing calculus.
This is the best job in the world. This never happened in Kruger Welding. Right. Ever. If I would have done that, I would have been fired again.
Again.
Yep. Three times my father fired me.
No, we just went down early and like watched.
Always look on.
Oh my gosh. Yeah. Got there like before the Herman game.
Would you like a pencil?
Yeah, I'm trying to find a good one.
Yeah, I have a real good one right here.
They were okay. So
This is one of my favorites.
Like 5 cheerleaders.
Needs to be sharpened though.
6 students.
Does the eraser
And
work?
It's a really good
like,
eraser.
and then maybe like a couple sets of parents. So like nobody, and we literally, our team had like probably like 20 or 30 people there before like their game even started. So, and we knew our fan buses were coming, so we just went up to them and we're like, hey, we're sitting in the section next game. Can we just like cheer for you guys and like sit here and like be a part of your fan section? And they're like, that would be much appreciated. And
They
so
had like 10 people.
that was so awesome. It was so cool. And then our fan buses came at like halftime, so we literally filled their entire side of their gym and just started cheering for the Hawks. Like everyone who was like, we came in, we're like, okay, blue and gold, Hermantown Hawks. This is like who we're cheering for. And so we were so loud and it was so amazing. Cool.
And where is this? Yesterday's game?
Yeah, it was the game before us, and they just like didn't have anybody there to cheer for them, so we just cheered for them.
Also, the We Love Pet Fan cheer was unexpected.
We do. We love Pet Fans so much.
I don't think you realize how much I love
Exactly.
Pet
That was my last Pet Fan event, and I'm really sad.
I love Pet
Oh,
It is the best.
I got it.
But yeah, it was so cool. And like the
I
cheerleaders,
got
I went
it.
into the studio.
It came to me.
What
was it,
They
Sean?
had
It's tea.
Pet
No one
Fan.
was drinking tea.
I'd rather
Okay.
just go sit
So I
with
just
the
need this
parents.
thing. Can we like put this up?
So
You know, we're live and have not done any calculus at all. And I've been listening. Somebody has solved a non-calculus problem. And somebody's been telling a story about us cheering for a team that did not have enough fans.
Kruger, I need notes.
You need notes?
If I get this during this class,
What?
Kruger, I just sprint out of here.
Where were you?
I don't know.
So,
Come up here. I have some.
this is the only thing I don't have.
Anybody else need notes?
Are we actually
Emma,
starting now?
do you need notes? Yesterday's notes?
I'm gonna have these.
Where do we go right now?
I do.
Haley, I don't do it yet.
Yeah, I know.
What?
Hi, we're actually starting now.
Okay,
Everybody be quiet.
So weird.
We're starting calculus.
Let me restart.
You have this.
Yep.
Oh, man. Alrighty. So, the limit comparison test. A couple things. You're going to, again, create a series that you're going to compare to, but you're going to create a ratio. It doesn't matter which value, which series you put on top. I kind of have a particular order that I do it. You're going to again pick a series that is either divergent or convergent. And you're going to take the limit of that ratio. And if that ratio is 0 or goes to infinity, you don't have an answer. So it needs to come to some numeric value that is not 0. The one you'll use the most is the P series. I think I use one with also the geometric series, and maybe the first one is that way. But usually I use a P series. And I'll give you an example. The other thing that you need to do is you should focus on the highest powers of n, both in the numerator and the denominator. And I'll show you that when we get to problem number 2, example 7, I think it is. So here's this particular one. This was example 3, and we determined that it converged before. So I'm going to look at it a little bit differently. And so I'm going to start out by saying a sub n is my given term in my series. So in this case, it's 1 over 3 to the n minus 1, or minus n. And I'm going to compare it to b sub n. And I did this the first time on example 3, and it didn't work. So I'm going to do it a little differently this time. And I'm going to have that being 1 over 3 to the n. The reason I did that is because they look exactly the same. I also know something about this particular series, it's geometric. R is equal to a third. And again, I can look at it like this. And it's convergent because R is less than 1. So what I'm going to do is I'm going to create a ratio, and my ratio is going to look like this. I do it in this particular fashion. It's kind of an alphabetic order fashion. I'm going to have the limit of A sub n over B sub n. And if it's convergent, if it is not equal to 0 and not equal to infinity. So this is going to become the limit as n goes to infinity of 1 over 3 to the n minus n over 1 to the 3 nth power, like that. Which can be rewritten as the limit as n goes to infinity of 3 to the n over 3 to the n minus n. What's nice about this is we're going to end up using L'Hopital's rule. And we can see we have an indiscriminate form of infinity over infinity. So I'm going to take the derivative. And Deva, what's the derivative of this, of both?
3n times ln 3.
And on the bottom?
Is the same.
Almost the same.
Minus 1.
Right? So again, I get an indiscriminate form of infinity over infinity. Deva, would you agree with that?
Yes.
Okay, so I can use L'Hopital's rule again, correct? And what will I get?
ln, or 2 ln 3 squared.
Yep, because I'm going to multiply by another ln of 3 times 3 to the n. And what about on the bottom?
Same thing.
Same thing. Because that constant goes to 0, correct? So what's my limit? Well, I could do this, can't I? Can't I simplify them?
Yes.
Okay, so what does it become now?
1.
1. So that's neither 0 nor is it infinity. So this series converges. All right, let's look at example number 7, which you can take a look. This is a pretty complex series. And what I'm going to compare it to is I'm going to compare it, I'm going to call A sub n again. I think you can see that okay. I'm going to call A sub n 4n squared plus n over, I'll write it like this, n to the 7th plus n cubed to the 1/3 power. And I'm going to create b sub n, and the way I'm going to do it is I'm going to look at this degree. This is n squared, so I'm going to write n squared here. And that's just that highest degree. So if this was n to the 5th, I would have written n to the 5th. And down here, I'm going to write n to the 7/3. And what I did is I just took n to the 7th and I raised it to the 3rd power. And this can be simplified. Yes? Okay. This can be simplified to 1 over n to the 1/3.
Just get over.
Yep. Are you okay where the 1/3 came from?
No.
Okay, I subtracted the exponents.
Yep.
Okay.
This is 6/3, 7/3, so it simplifies to 1/3.
Got it.
So what is this? P series, excellent. What does this P series do?
few reasons.
It diverges. Why?
P is less than.
Because P is less than 1. So my only answer on my comparison test is that it diverges, because I'm comparing it to a diverging series. Does that make sense? Converging is not an option that I'm going to have. So again, I'm going to write it in this form. I'm going to have the limit as n goes to infinity of a sub n over b sub n. So I get this. The limit as n goes to infinity of 4n squared plus n over n to the 7th plus n cubed to the 1/3 power times n to the 1/3 power over 1. So I multiplied by the reciprocal. And this is going to be the limit as n goes to infinity of 4n to the 7/3 plus n to the 4/3 over n to the 7th plus n to the 3rd raised to the 1/3 power. So what I did is I distributed that, and when you multiply through, you're going to add those exponents. So I get 2 1/3, which is 7/3. I get 1 1/3, which is 4/3. Okay. The degree of this is.
Why is it not 2/3 instead of why is it 7/3? Oh, because you're adding them now.
I'm adding, because when I multiply bases, I add the exponents, because I have n to the 2nd times n to the 3rd.
Yep.
Okay. All right. So, what do you think the answer is? That limit.
It's gonna be 4.
It's going to be 4. Perfect. How did you know it was 4?
The exponents are
Yeah,
equal.
yeah, because I can rewrite this, so this is n to the 7/3 power, correct? And I got n to the 7/3, so you're going to look at those leading coefficients. This is a number that is not 0, and it's a number that's not infinity. So that means this series, I guess it starts at 2, of a sub n does what? Well, since this diverged, and I came up with a number that is not 0 and not infinity, this must do what? Diverges.
So why is the n equal to 2?
Because that's how it was defined.
Oh, yep.
Yes, ma'am.
So if that limit diverged and like both of them diverged, would it still like in the end diverge? Like would it then diverge?
Oh, if it would have went to infinity,
Yeah.
our answer is we don't know.
Got it.
Okay, it's got to come to a non-zero constant.
So if it was
The reason that it diverges is because the p series I have diverges. So I created a ratio that is divergent. Okay, I used a ratio. I used the series in a ratio that is divergent. My only result I can get is divergent.
okay.
If I would have gotten 0 or infinity, then I don't know.
Got it.
And then I use a different test.
If you figure out that the p series is divergent, you just kind of have to figure out whether you know it's divergent or you know.
Right, that's why right here when I pick this, okay? And the reason I picked this was because of these degrees here. Once I get to here and I say, all right, this is the one I'm going to compare it to. What do I know about what it is? And so I say, well, I know it's a p-series. Okay, now, is it divergent or convergent? I write that down, and then I write why I know that to be true. Okay?
So on the first one, when it converges for your B sub n, can it diverge and converge, or can it only converge?
It can only converge and it can only diverge. It only can have a limit or not have a limit.
So it can be both on the first one?
No,
Oh.
no. And so when I chose this one, if I had there's not a divergent series in which I would have got a value. Does that explain that?
Yeah, so if you compare them and the bottom ends up diverging, you just don't know what it does?
Exactly. Okay. Now, if you notice, I did this on example 3. Okay. So there are different tests. I mean, Jonathan could say, because you'll be asked to find out whether this series diverges or converges. You'll be asked that. People can come up with the same results using different tests. So it's the result that's important. It's not the test that's important. Does that make sense? Yeah.
On the quiz, are you going to tell us which one to use, or are we just...
I think I do ask. I think maybe the last one, I leave it up, but I'm going to ask. I want to make sure you know how to use the tests. So I think I'll say I want you to use the comparison test here. I want you to use the limit comparison test here. I want you to use the integral test here. Okay? Okay? So again, here's this one. Okay? So I'm going to start this way. And I think you're okay with this. What do you suppose I'm going to choose for B sub n? Hi, Maggie. Welcome.
She didn't know she was there. Because
No, I didn't even know she was there. Oh,
Say hello
Sorry.
to us.
yeah, because he can't just salt out the new banks and then not salt out everybody else who comes in.
2n over 5n.
she didn't scare me like other people do. Okay, what am I going to use?
2n over 5n.
2n over 5n. Perfect. Okay? What is that? And when it's this form, to be honest with you, I don't always see it.
Is it 2/5?
What's 2/5? What do you mean, 2/5 to the n power? Is that what you want me to write, or just you're telling me something's 2/5?
Well, if
Oh.
they have like the same,
Square.
is it convergent?
Okay, it's convergent. Why? What is it?
Because the exponents are the same.
Correct.
It's geometry.
Well, okay, it's an infinite. You have a variable that's an exponent. So you need to tell me what kind of series would this term make?
Geometric.
Geometric. How do you know it's geometric?
Because n is the exponent.
Because n is the exponent, okay? So is it convergent or divergent?
Convergent.
Convergent. Why is it convergent?
Because r is less than 1.
Because r is less than 1. R is equal to 2/5, correct?
If it were 5 seconds, it would be divergent.
Correct. So now I'm going to have this as my limit. So I'm going to take a little shortcut here and see if, make sure I don't lose you. I'm going to have this 2 to the n plus 1 over 5 to the n plus 1 times 5 to the n over 2 to the n. So if I multiply by the reciprocal, isn't that like dividing by b sub n? Okay.
What'd you do?
I have pennies on the floor.
So what I can do is I can rearrange this one and have 2 to the n plus 1 over 2 to the n times 5 to the n over 5 to the n plus 1. Are you okay with that algebra? Okay. Limits of products can be broken up as products of limits.
What?
Limits of products can be broken up as products of limits. So in other words, I could do this. Okay?
Where did you get the 5n plus 1 on the bottom again?
Well, this is a sub n, correct? This is dividing by b sub n, multiplying by its reciprocal.
Yep.
And then all I did was multiply them in a different order.
You can do that.
Yeah, 3 times 2 is the same as 2 times 3.
Okie dokie.
Okay, right? I can multiply in any order I want. If I have 3/4 times 5/6, that's the same as 3/6 times 5/4. Okay? So, L'Hopital's rule, would you agree? You got infinity over infinity. So if I take the derivative of both of those, I'll have the natural log of 2 times 2 to the n over the natural log of 2 over 2 to the n.
You can't just say it's 1 because the exponents are the same.
That's an Alex Martin's argument,
That's what I was.
okay, which the answer is yes, you can, but I can use L'Hopital's rule to prove it.
Wait, so
But do
we
you-
have to since they're.
have to though?
'Cause,
Would
like,
you,
literally they're the same.
is your argument that this is 1 times 1, which is 1?
Yeah.
Yes.
I would accept that as your argument, okay. But if I asked you to use L'Hopital's rule to demonstrate that that's correct, you should be able to do it. Would you agree?
Yeah.
Okay.
Seems like an Alex Martin.
Of course, it should be on.
Alrighty. Not bad. It's not, it takes a little while to get used to. It's kind of similar to the last one. All right, we got 2 left. Alrighty. A sub n.
Wait, can I just ask something?
Yes?
So like the 2 to the n plus 1, that term, how would you take the derivative of that?
This right here. Would I take the derivative of this? The derivative of this is the ln of 2 times 2 to the n. The derivative of this is 0. And then down here I'd get the ln of 2 times 2 to the n, which is 1. So I need to write this down.
So you don't have to do the quotient rule?
No. Mm-mm. No, L'Hopital's rule is not the quotient rule. It's simply saying you can take the derivative of the numerator separately from the derivative of the denominator. Okay? And so I need to write this down. I need to write this statement down. N equals 1 to infinity of a sub n, since I said what it is, converges. All right, so a sub n here is this. What's b sub n going to be?
N to the third.
Oops, I forgot my parentheses. What?
1 over n to the third.
1 over n to the third. Okay. What is this? P series. Converge or diverge? Diverge. What is it? It's converge, isn't it?
Yeah.
I thought I heard diverge. I'm sorry.
Definitely did say that, so.
Okay. Why does it converge?
Because P is greater than 1.
It's P is greater than 1. So I'm going to have the limit as n goes to infinity of n to the third over n to the third plus 3n squared. Again, what I did was when I divide by b sub n, I multiplied by the reciprocal, and I just jumped to there right away. Okay? So this limit is,
Yeah, couldn't it be just 1?
yeah, so that's what it is, exactly 1.
exponents are the same.
Yeah, it's the leading coefficients. Okay? So that means n equals 1 to infinity of 1 over n squared times n plus 3. I wrote it out this time, converges. All right, last one. A sub n is equal to n times 2 to the n minus 1 times n plus 1. And what is b going to be?
2n minus 1. No.
You're close. You're really close. You're like 98.9% close.
2n.
1 over.
1 over 2 to the n minus 1. Now, why did I choose an n? Because this n over n is going to simplify to, do you see that limit's going to be 1? Right? So really you only have to deal with this, correct? So, what is this? It's the same as this, right?
Your geometric.
It's geometric. What's it do? Converges. Why? Right, r is a half, and that's less than 1. So now I have the limit as n goes to infinity of n over 2 to the n minus 1 times n plus 1 times 2 to the n minus 1 over 1. Well, this is going to simplify. These have the same degree, so my limit is what? 1. So this converges.
When it would diverge if it was 0 or infinity?
Here?
If it was 0.
No.
infinity.
No, an converge. Nope, never mind. Yep, got
If
it.
you get 0 or infinity, you don't know.
You don't know.
It's neither diverge or
Oh, you're right.
converge.
Does not
It's
differ.
dependent upon the series that you use. Okay, yep.
Okay, so if it's 0 infinity, what do you write, or like how do you?
You write down, I don't know.
Okay.
And we aren't going to have anything that is 0 or infinity then?
Well, you're going to end up, okay, I am going to give you a problem down the road in which you are going to pick your test, okay? And if you get a test that it's I don't know, then you need to pick a different test,
Oh boy, I can't wait to
okay?
hate everything.
Okay?
How can you know with one test without knowing another? Like, how does that work?
Well, okay, like the first one I do,
It wasn't this one.
okay? If I were given a test, the first thing I do is I take the individual term and I take the limit of it. And if it's a non-zero value, I know that series diverges. Boom, that's the first thing. If I get 0, then I look for a different test. I look to see if it's geometric right away, because geometric is an easy one to find. I look to see if it's p-series, okay? I'd like doing the comparison test because I can compare it to one of those two, okay? And then the one I use at the end is the integral test, to be honest with you. That's kind of the order that I go through. It's where you integrate the term to see if you come up to that it has a limit, and if it has a limit, it converges. Okay? Alrighty, I am done for the day.